code, and your final unit is going to be what? A capital J or joules. That's what we measure. That's our unit for energy. Okay? Number 2, a cinder block sits on a platform 20 meters high. If it has a mass of 8 kilograms, find its energy.
Ethan has a question.
Huh?
Ethan has a question.
I'm sorry, what is it?
No, I can't see.
Absolutely. Okay, so this one, a hint, what we're going to do, it tells you a height. And so when you always use a height when you're calculating gravitational potential energy. So we're going to use a gravitational potential energy formula, which is gravitational potential energy is equal to ham, the word ham, okay, which is height times acceleration due to gravity times the mass. Okay, so let's list what we know over here. The GPE, we don't know what that is. We're supposed to find that. So I'm going to put a question mark. The height is equal to 20 meters. So I'm going to put 20 meters there. Then A, which is your acceleration due to gravity, that's a constant. It's always the same number, which is 9.8 meters per second squared. And then M, which is mass, they tell you that is 8 kilograms. So I'm going to write that in right here. So now I've listed what we know. Now we're going to solve for what we don't know. So GPE is equal to the height, which is 20, times the acceleration due to gravity, which is 9.8, times the mass, which is 8. So you just take all three numbers and you multiply them together, and then the final GPE is equal to 20 times 9.8 times 8. And what is our final unit going to be in? Joules again, right? A capital J. Good job. Okay. Number 3. Let me move up a little bit. Number 3 is a little bit tricky, but we're not going to let it trick us. We're going to figure it out. A baby's car seat sits on top of a bench 2 meters tall. So once again, we have a height there. So that gives us a hint what we're going to be using. The baby and the car seat have a weight of 12 newtons. Find the energy of the baby and its car seat. Okay, so what the tricky part is in this problem, they tell you you have 12 newtons for the weight. So I want you to know that weight is the same as a force. Weight and force are, for all practical purposes, the same. Since we have, they give us a height here, we know we're going to be working with gravitational potential energy. And so our formula for gravitational potential energy is, remember, the word ham, height times acceleration due to gravity times mass. But they give us a force in newtons, and so we have to go back and remember in a previous unit that we learned that force is equal to mass times acceleration. Okay, and if you'll notice in our gravitational potential energy formula, you have mass times acceleration right there. So what we're going to do is we're going to take the force and we're going to substitute it right here in our formula for mass times acceleration. And that gives us kind of a new formula, and it would be GPE, gravitational potential energy, is equal to the height times the force. But I want you to realize all of these two, this formula and this formula, are really the same thing. You're just substituting in a force because force is equal to mass times acceleration. Okay? So now let's list what we know and solve for what we don't. So gravitational potential energy, that's what we're having to find. We have a height given to us, which is 2 meters. And then we have a force, which is 12 newtons. Okay, so when you plug all those in to solve for gravitational potential energy, you say the height, which is 2, times the force, which is 12. So the gravitational potential energy is equal to What's 12 times 2?
24.
Good, 24. And then our unit for gravitational potential energy is what? Joules, capital J. So that's our answer for that one. Okay? Y'all understand how we did that? All right, I'm going to move up a little bit. Number 4. A 1,120 kilogram car is traveling with a speed of 40 meters per second. Find its energy. So they give us a mass and a velocity. So we're going to use that kinetic energy formula. Kinetic energy is equal to 1/2 mass times the velocity squared. So when we go over here and we list what we know, kinetic energy, that's what we're trying to find. So we're going to put a question mark. We don't know what that is. The mass of this car is 1,120 kilograms. And then the velocity is equal to 40 meters per second. Now we just plug in and solve for what we don't know. Kinetic energy is equal to 1/2 times the mass, which is 1,120, times the velocity, which is 40. And remember, the velocity always has to be squared. Okay? If you're to take 40 and square it, or you say 40 times 40, what number do you get? Forty times 40 is equal to what?
80.
No, that's 40 times 2. 40 times... If you were to plug it in, do you think you'd get that? You would. You would get 1,600. 40 times 40 is 1,600. So the answer to this question is the kinetic energy is equal to 1/2 times 1,120 times 1,600. And what is your final unit for kinetic energy going to be? Same as what it is for everything else. Joules. When you calculate the energy. Joules. Capital J or joules. Okay? And you do the math and figure out what that is. Okay, so number 5, let's look at that real quick. A bell is hanging at the top of a tower. It has 8,550 joules of energy. If it has a mass of 20 kilograms, find the height. So this is one where you have to find the height. Whenever they ask you about the height, you know that has to be gravitational potential energy, because height, that's the only one that has height in it. So the formula for that is gravitational potential energy is equal to the word ham, which is the height, times acceleration due to gravity, times the mass. So let's list what we know. Gravitational potential energy, they tell us that is 8,550 joules. Height, we don't know that. They're asking you what that is, so we're going to have to solve for the height. A, or the acceleration due to gravity, remember that's always the same. It's a constant. It's always the same, which is 9.8 meters per second squared. And then M is your mass, and they tell you the mass is 20 kilograms for this problem. So now all we have to do is plug in what we know and solve for what we do not know. So GPE, they told us, was 8,550 is equal to the height. We don't know what that is, so I'm just going to put the letter H, times the acceleration due to gravity, which is 9.8, times the mass, which is 20. Okay, so... 8,550 is equal. What is 9.8 times 20? 1150? 196. Okay, 196 H. Now right here, I just took 9.8 times 20, and then I just put H next to it. Okay, now I'm going to try to get H by itself, so I'm going to divide both sides by 196. And so that cancels out 196 on this side and gives you H all by itself. So H is equal to 8,550 divided by 196. So that number is going to be what you put over here, along with what unit are we going to put for our height? It's usually listed as what? In meters. Good. So whatever number you come up with there, your unit will be in meters. Okay? Now let's look at the challenge. Piece of cake. So easy. Number 6. What is the mass of an object that has 324 joules of energy and is moving at a speed of 9 meters per second? Okay, so this one is going to be a kinetic energy formula because it gives you a speed or a velocity, and it's asking you for the mass. So we're going to say the kinetic energy is equal to 1/2 mass times the velocity squared. So let's plug in what we know. Kinetic energy is equal to 324 joules. Mass is equal to, well, they're asking you what is the mass, so we don't know. We're going to have to find that. And then the velocity is equal to 9 meters per second. Now we just plug it in and solve. So we say 324 is equal to 1/2 times m times 9, which is the velocity, and it has to be squared. So what is 9 squared? 81. And what is half of 81? 40.5. So can y'all see how I would go from this 1/2 times m times 9 squared to 40.5 m? I'm just going to say, I'm going to do it like this: 1/2 times m times 81, and then 1/2 times 81 is 40.5. So 324 is equal to 40.5 m. Now to get m by itself, I'm going to divide both sides by 40.5. And then 40.5 cancels out right here. And m is equal to, and what do we measure mass in usually? What? No, that's energy. Energy's in joules. Up here, what have we been measuring our mass in? Like right here. Kilograms, right? So your unit down here is going to be kilograms. Whatever number you get, it's going to be kilograms. Okay? Yeah.
Can you scroll up to the very first problem? I didn't get to see that one.
Okay.